today I'm going to talk, I've been following and talking about low power WANs. That's how I got started. I told Maria about weightless technology, which is now called weightless W, 3 years ago. And she said, I told her, I said, I need to come and talk to IEEE about that. I'd be glad to do it. And 2 days later, she called me back and said, yeah, we'd like you to come in. I said, how many months do I have to plan? 8 days. So I had to put together a presentation from the ground up, and I reached out to William Webb, Professor Webb in the UK, who did a lot of research at their FCC and created what now is the weightless W standard. And I've followed him for the last 3 years. I've spoken 5 times a year since that time, and I've been watching. These guys, Ingenu, have been kind of the backwaters. They're committed to the utility, or focused on the utility and now the oil and gas industry, but that's it. And I'll tell you more about what's happened here recently to bring them into the limelight. But
and don't they do a lot of government too?
I think so, but they don't talk about that. They talk about the utility because they're in San Diego. And again, I'll go into more detail in a moment, but their backyard is San Diego Gas and Electric, and that's where they got started. So I'll give you a level setting so we all appreciate and understand what M2M does and what I consider the 3 parts of it. And then I'll talk about low power WANs just in general, who's the player in that space, players, and then I'll talk about Ingenu. All this data is public information. Google is awesome, and I want to thank all these people that provided information that I've pulled for my various reports over the years. And as we all know, M2M has been around for a long time. Probably talking back in the early 1800s with telegraphs, and it's considered the first M2M system. But we call it telemetry, telematics, data, sensor network, whatever. And we've used wireline and microwave private radio networks and cellular and satellite to be able to connect devices back. Now, what's going to happen is we all know we're on the cusp of a tremendous inflection point that's going to change the world. Good or bad, I'm looking at the good, and I'm trying to take advantage of it and build our community and give us something to focus on in a positive way. So we've got security guys here, so hopefully they can keep us out of trouble, keep the NSA out of our lives. But anyway, so
No.
yeah, I know that'll never happen. But anyway, so I consider the 3 components of a machine-to-machine and Internet of Things capability as the devices, objects that are in the field, then the connectivity, whatever that is, to get that information back into the back end. The back end is an incredible amount of technologies, and you do a week-long seminar, all the different aspects of the back end that need to be improved and expanded to be able to handle all this influx and tremendous amount of data that we're going to be collecting and trying to analyze. So I'm going to talk about the wireless part. In the past, we've had cellular. Cellular actually turned out to be pretty good because it was pretty ubiquitous. It's over 900 entities involved in the 3GPP standard around the world, 650 or 600 some odd different carriers around the world. So when they had the 2G network, that was a pretty good network. It didn't have a lot of handshaking. It was pretty simple to be able to connect to remote devices. If you had a valuable device, a car or something that had a significant value to you, then it was worth it and economically feasible to use a cellular modem to put on that device. And if it had a power supply, then you were good. If it didn't, that's a different story. You could run out of battery capacity very quick. So it has its place. And now they've gone to 3G and 4G and coming 5G. They're going this way. High data bandwidth requirements, high power, lots of chatter, a lot of handshaking going on. The other end of the spectrum here is the Wi-Fi, the short-range technologies, the Zigbees, the Bluetooth Low Energy. Pete?
What about LTE-M?
Yes, well that's one of the things, and I'll talk about that a bit more in a moment. But yeah, this another one of the cellular capabilities that they're working on, and I'll get to that in a second. But so we've got cellular, broadband, high power, expensive. We've got Wi-Fi, short range. To put them together is going to be expensive to create large networks. We're missing a piece in the middle. That's going to be the low power WAN systems. Now I've been tracking probably 6, there's a lot more than that, but there's 6 people that have caught my attention that I'm keeping tracks on. Nick is involved with the LoRa. Nick, where are you? He's involved with the LoRa stuff, and it's catching fire. They're getting a lot of good press, and they've got a good technology. Sigfox, everybody knows about Sigfox. They've got $218 million. That's 100. I knew of 150 million, and Nick says now they're up to 215 or so $1 million in money investments and whatnot. And they're committed to putting a network pretty much on every continent in the world.
Just one thing to add, they have a franchise model, so their franchise owners in different countries also tip in money. So they're not having to fund their network build out from their own cash flow.
Plus, on top of that, they're also doing some private projects. So one of the things which is kind of not really well publicized is they're lighting up the 30 largest airports in the United States.
Yeah.
As an example.
Yeah. So Sigfox has a significant following, money, great marketing machine, very simple, straightforward technology. So they're going to have a place to play. They're a niche, I believe, and they're not going to fill the bill for everybody. And I'll talk about that more in a moment. So we're going to have stratospheres inside even the low power WAN area of capabilities that supply and serve certain customers and certain needs. So I'm focusing today just on Ingenu because of they've come out of the backwaters here recently. So you got cellular up here who has a niche and will continue to always have a place to play. You've got the Wi-Fi and short-range technology. So the short-range technology stuff is in the purple, if you will, or what is that? What's my color? Is that violet? and then the blue is cellular. Fuchsia. There we go. I like that. But pilot analysts say anywhere between 60 and 90% of the Internet of Things connectivity requirements are going to be fulfilled by low-power WAN technologies. So no matter what it is, it's going to be a lot of opportunities for people in the low-power WAN space.
What's IOO?
Where did I put IOO?
Internet of Objects? Is that what you said?
Hang on, let me go back. Yeah, Internet of Oops, what it was probably. Where am I? Oh, this was, the Internet of Objects. This was a slide presentation by Simtech. And so there's more information that they talk about that. They call it.
They don't like things.
No, and neither does Cisco, so, whatever.
Everything.
The original research for this comes from Mac.
Yeah, I mean, a lot of people are calling it, they all want to put in their own branding.
Yeah, exactly. So I think IoT just makes it easy, it rolls off the tongue. So, as most people know, the characteristics and requirements of a low-power LAN network is that, one, it needs to be low power so it stays under certain requirements for, if it's in unlicensed frequencies, it has to meet FCC and other rules of other countries and whatnot. But the main thing is, by being low power, then it maintains the battery, it keeps the battery, and the goal is to have the batteries work for 10 years at least in the application. But a lot of these things that we're going to be able to monitor and instrument are going to be in places we don't want to go, but once every 10 years or even more. So we don't want to keep changing the batteries and go and recharge them and that kind of thing. They're going to be off the grid. They're going to be small sometimes or in hostile environments. So it's got to meet that requirement. And then the network, it needs to be low cost. So the cost for the devices needs to be very low. The cost for subscription on those needs to be very low as well. So the more ways you can reduce the cost of the infrastructure, the more you can pass it on and create a very compelling business plan. Then it needs to be scalable. The systems need to be portable. So you may put a device in one place, but it may wind up getting moved at some point. It may not necessarily be mobile all the time, but it may be moved, and it needs to be able to reconnect with an access point very easily. And it needs to be reliable. So these are the players that I've been watching for a while: Sigfox, Ingenu, LoRa, the Weightless N, which is N-Wave, and Paul Peck is the COO and CFO of the U.S. headquarters for N-Wave, right here in Richardson, and it's built on the Weightless N protocol, which is an open standard. So anybody can build to that. And then we got Weightless P, which was just ratified in January. It is I consider Sigfox and N-Wave to be at this level, pretty straightforward and simple, and it has its place. Then you've got LoRa and Ingenu and Weightless P at this higher level, and then you got cellular 3GP stuff.
So
which is the last one
lower
down here.
level and higher level, what do you mean by that?
I mean by the amount of data that can be transmitted. So N-Wave and Sigfox talk about very simple
very small
messages,
packets.
short packets going back and forth, right?
Okay.
Ultra narrowband typically. And then LoRa and Weightless P and all are more spread spectrum, can handle more data throughput, yet they can be variable in the packet sizes. And then the 3GPP, or NB-LTE or NB-IoT is the cellular standard that they're working on. 3GPP put it in as a work item late last year. It's going to be in the release 13 that will be coming out the middle of this year. Yes?
Which of these standards are capable of supporting bidirectional communication?
I'll talk about that in a moment, but LoRa can. All of them support some form of two-way. Sigfox and N-Wave, and correct me if I'm wrong, Paul, the device initiates the call.
The chirp.
The chirp, if you will.
It's a
And
receive
then-
window triggered off of the transmit sequence.
Yeah, whatever happens, an event happens at the real location, then that device sends a message back to the access point. The access point then signals back, and that's where the two-way comes in. The remote device then, in Sigfox and LoRa, says, oh, I got it. So they don't keep transmitting. Or they transmit
Is it
blind
chirp-
and not know.
Is it just the chirp, or are they actually communicating data information?
No, they're control, right, Paul? You can do control from once the decision's initiated.
There's two categories we're interested in and we're supporting. One of them is just ACNAC, to assurance of communication took place, and the other one is, although we could open up big enough window to completely reflash the firmware, that's a battery hog, right?
Right.
But we are designing our firmware parameters where you can send short chirps of telemetry adjustments to the parameters of the
Right,
firmware.
and you do it for management of the sensor.
Yeah, we could do it. We could do it where we download a Netflix video, but the battery would be on about a day. Yeah.
Right.
And then Nick can speak to this maybe a little bit more, but in LoRa, you have three classes of the devices. So one is, they're very similar to Sigfox and LoRa, Sigfox and N-Wave, very simple communications. Then you step up and it has more two-way capabilities, and you can go to, it's always listening and transmits only whenever it needs to talk back. So LoRa can be very flexible and powerful, depending on what your needs are. Yeah, Paul?
Yeah, in the Sigfox case, it's kind of moot. They supply the network, so you don't really think about how many base stations there are and where the connectivity is. But on these others, you have to provide the base station, right? Sigfox is on, if I understand correctly, Sigfox is the only one on the chart where
Well,
base station included.
no.
Okay.
It's changed. Okay, that's what I'm talking about today, because I'm excited in that something was announced in Barcelona.
Okay.
Okay. And
So
we'll go into that detail, but
I'll
yes.
wait. I'll save my question.
Yeah. LoRa is very good about giving you the base station. People, and Nick is part of, how many networks have you seen go up now?
Couple thousand.
So, and that's in the States, or is that in the world?
That's globally, but they support private and public networks. So
Yeah,
public
right.
networks are like AT&T, but private ones you just buy your own stuff and
Sure.
build it anywhere you want.
So-
So all of these
Yeah, that's what we
technologies except Sigfox have previously supported both a private and a public. Sigfox was public only.
That's the differentiation I was trying to.
Yeah.
Is that differentiation still true?
It's changing. It's
Okay.
evolving. This whole thing is evolving. That's the exciting part about it. You need to keep up because things are changing every
I wanted to go to
week.
Barcelona last week. But,
Yeah. So you didn't go, so you're back. So,
our reading stack got bigger.
So we'll, keep tuned, because things are going to be changing a lot. And that's the exciting part about this. New technologies are going to be identified and brought to market. This is what I've seen so far, and there are other things in the wings that could come in and totally radicalize, could completely change the way that we do low power winds now. But right now, these are the leading contenders in this space. So I'm going to talk today about Ingenu. Now, Ingenu used to be called ONRAD. So we're going to take orders here and order breakfast, and then they'll bring you breakfast in as we're making presentations a little while. So. Does everybody have a menu?
No.
Can you pass out some menus so that nobody has a menu?
Oops.
Yeah. They do a great job. At,
This could be expecting.
So the ONRAP got started. ONRAP was the original name. It came out of Qualcomm. Two engineers left Qualcomm. You know anything about Qualcomm? They worked with the NSA. They were the ones that created the CDMA standard many years ago. Pretty incredible technologists and business people that ran that company. And two engineers came out of them in 2008 and created ONRAP. And they recognized that machine-to-machine needed a very useful, powerful, flexible protocol in that space. This is long before we got the Internet of Things. And they had a customer right there in San Diego Gas and Electric, who was looking at distribution automation and other ways, the pre to the smart grid, the pre-technologies and whatnot approach. And so they formed, had opportunities to sell it to them, and then they began to go into utilities and oil and gas. But that's where they've stayed now since 2008. But they've been expanding and evolving the protocol, the technology that they're using there. And that's been 7 years now, 2008 to 2016, 7 to 8 years. So it's very powerful. These guys, if you know anything about Qualcomm had very sophisticated spread spectrum technology. And so they've applied that to what they're doing with the Ingenu protocol. And they've added very adaptive encoding, and I'll talk a bit more about that in a moment, as well as dynamic controls for the transmit power, tight transmit power, and that's very useful in what they're in the needs of the future when they expand and increase capacity of the system. And they got forward error control. They can actually get half the message wiped out and reconstruct the message. That's how powerful the technology is and the forward error correction, the technology they're using. They have very high receiver sensitivity. Now, they operate at 2.4 gigahertz. All the other guys that I'm going to talk about, unlicensed 2.4. It's Wi-Fi frequencies, and I'll talk about that more in a
It's
moment.
Wi-Fi what?
Wi-Fi frequencies.
Yeah.
It is in actual 80 megahertz worth of frequency that's allocated to Wi-Fi, public Wi-Fi.
The Wi-Fi protocol?
No, it's not. And I'm going to talk about it in a moment. It's a very different protocol. And they do some really interesting things to coexist with Wi-Fi. So, because they're at 2.4, they automatically lose 9 dB of receiver sensitivity. When you do analysis, you go into, you convert all your power, all your antenna gains and your cable losses and free space losses and that kind of thing into dB. They make up for the 9 dB loss they get just because they're at higher frequency with the higher receiver sensitivity and diversity antennas and the protocols that they're using. So that the attenuation that happens at 2.4, they make up for it with all the other technologies they're using. Yeah, Dallas?
Well, in that case, then will it operate at the noise floor or below the noise floor?
They will operate with DSS. So, yeah, it's
So
whatever.
They have to stay. They have to basically stay at low noise for a certain dB range, right?
Yeah, I haven't studied that. I've been trying to dig into all the details, and I get certain amounts of information. I don't know about where they sit in the noise floor, but they've got a lot of technology to recover and receive what little signal they get. So high receiver sensitivity.
I heard them saying that it's actually they can operate below the noise floor.
How far below the noise floor?
I have to look up. I have a presentation.
Yeah.
So, in addition to the technologies and the protocols and the ways they make the signal as useful and travel as far and penetrate as much as it can, they also have evolved the security of their system because they are working with utilities and oil and gas, and security is very important. So they've evolved and added a lot of security capabilities to their system, and then it has to be reliable. And so that's what they've come up with, is some very reliable techniques to make this thing very useful for them a long time. So they call their protocol random phase multiple access. Nick?
What's the indoor coverage look like with this technology?
Yeah.
Well, they claim that and this is all marketing stuff that I've been able to read, they claim they penetrate very well into buildings and into vaults.
So very well is a real fluffy.
And so I've always talked about the fact that anything above 1 gigahertz acts like light. It doesn't get very well into buildings, or not in vaults. But they've been doing this for 7 years now, and they claim they've got meters and they've got instruments inside buildings, deep in buildings and deep in vaults and underground that they're talking to over a mile away. So the great thing is they're installing a network here in Dallas and will be turned up the end of March, end of next month. We will get to see how well it penetrates into these places.
Yes.
And we're going to be drive testing and putting our devices in there and see where we reach.
And that's a really good point with Ingenu because they announced that they are lighting up a public network of 25 cities.
Oh, you stole my thunder! No, don't listen to him. Let me get to that in a minute. All right, Paul?
Is the RPMA technology available for licensing to others, like, for example, some of us that operate at sub 1 gig.
Now, I talked to the CTO, so I reached out to John Horn, the CEO. I'll talk about him more in a moment. He didn't respond to me. But the CTO, Ted Meyer, which was one of the early developers, and he's one of the two guys that came out of Qualcomm, he said, yeah, let's talk. So I called up and talked to him for 10 minutes. Well, I thought I was going to talk to him for 10 minutes. An hour later, we're still geeking out.
Okay, so just a kind of general question to the room here and the wireless guys. If all this stuff is true about the additional antenna gain and adjacent channel interference rejection and all these things they got, would they presumably, if they work well at 2.4, and I'm not saying they don't, it probably works great, would it work better at 900 megahertz?
Penetrate better.
Yeah,
What's that?
It would penetrate better for sure.
That's better in my book.
Right.
Yeah,
But it goes through concrete.
Definitely. Yeah.
So there's lots of pros and cons here, and the thing is, they're using a lot of technology and processing power, and the fact that they can use diversity antennas in both their remote and their base stations.
I'm
where
saying
you
we
can't
can do
that
all
at
those
low
antennas.
frequencies. So the beauty is going to be that we're going to be able to test it in the real world in less than 45 days, just over 30 days from now. We're going to be able to start doing some tests. In fact, we might be able to do it sooner than that, because I'll talk about it later in a minute. We'll have access to development kits here shortly. So we're going to be able to start testing it just as soon as they turn on the drive test. Yeah, Jeff?
And that's right in both of these.
Yes.
Okay.
So
They sell a module, but you.
That's kind of the downside, but we'll talk about that in a moment when I get to it. But yes, and yeah.
So I asked them actually why they didn't go with sub-gigahertz frequencies, and they said that basically they need antenna diversity, and that allows them, 2.4 gigahertz allows them to have much smaller antennas and much smaller space.
Well, that's what I was wondering. If once you go lower frequency, everything gets bigger.
Yeah.
Yep.
So.
Yeah, exactly. So there's trade-offs here, and you can theoretically debate this all day long. The beauty of it is, in less than 45 days, we're going to be able to test it and see how well it actually works in the places that we need it to work. If it doesn't, there's ways around that. So I'm going to talk about that more in a moment. So it's called random phase multiple access, RPMA. It's based on a direct sequence spread spectrum. For the geeks here, it's a differential binary phase shift keying on the baseband modulation, and it can upload 625 kilobits of potential. That's a heck of a lot. That's why. But the packet sizes can be modified in the size of the packets, and the power is tightly controlled. And there's another one here I'll think of in a second, that they have all these things that they can modify in the transmission, depending on what the condition.
So
Ahead of myself.
So do they have intermodal power management within at the packet level?
Yes, yeah, the transmission control, so they can reduce it. I'll talk about that in a moment when we talk about the cells that they're creating. We'll talk about that. And then the downlink can go up to 156 kilobits, and they have the ability to download lots of information if you need to update the operating system inside of a device out there. And then, so coverage. That's one of the things that they really talk about, because they've been able to use these protocols and whatnot to get great coverage as well as penetration, and we'll find out in a minute. They say that because of the approach they take, they can cover 300 square miles. So how far is that in range? I pulled up my map book. So the area in a circle is pi times r squared, the radius squared. And so that figures out to be just shy of 10 miles. So that's a pretty significant range when you're transmitting for a cell site. And so that's where you can get your 300 square miles.
So that's the guaranteed not to exceed distance?
Yes, yeah. They actually have at San Diego Gas and Electric, one of their customers, they don't say which one of their customers, they can do 450 square miles with one access point. But they're, based on everything that they do, it's 300 miles on the average.
But of course, that's, their building penetration is not that good, and,
That's got to be line of sight.
Yeah, that's what I said, out in the middle of nowhere, that would work.
yeah, I mean, that's not real world, right?
It does in an oil field. It's perfect.
Well, that's what it was designed for.
Or agriculture,
Or
right?
agriculture, right.
Yeah.
So we're going to find out here very soon, how well it works in the urban
The
environment.
orders of magnitude less than the 900 meg. So Digi has done a trial with balloons and mountains, and they get 90 miles.
90?
90.
Yeah.
90.
Sure. But you can't do that, obviously, at Surface area.
At 80,000 square feet, 80,000 feet, you can get as much as you want.
Yeah. If you have no free space loss and no other attenuation, you get a long way to signals.
And Laura and Sigfox are getting up around 25 miles with the same what I call BS marketing. Because it is garbage.
Yeah,
It's
yeah.
complete garbage.
And so that's the beauty of it.
We need
This
the
is all-
reality of, we need DB numbers.
Yeah,
What's your
right.
DB
Well,
loss?
what we
What's
need
your
is real world
propagation?
Real world
analysis.
test.
And that's what we're gonna find. We'll do drive testing. They'll do drive testing middle of March, and we'll be able to work with them after that.
But when are they going to disclose real numbers? Because this is stuff that people put in their early technology stuff to get VC funding. This isn't what serious technology is.
Well, we'll be able to know here shortly. So whatever they put in there, it won't matter. Because we will be able to test it out and find out.
You still have the physics of the matter. I mean,
Always.
Yeah, but you got attenuation, and so you got ways to recover when you got a little bit of signal. If you don't have any signal, you're right. You know, so if you're in a Faraday cage, nothing's going to get in there. So it just depends on where you're trying to talk to, and we'll soon be able to know real world what those capabilities
Yeah,
are.
but they-
And I'm looking forward to you guys helping us.
Are they going to publish the numbers? Because it's expensive to gather this stuff. It takes time and money. Whereas all the competitors you put up there publish the numbers, the real ones.
Well, I've been one person doing the research that I could, okay? So I'm about to give you all of the white papers, which they sent a 40-page white paper, then other analysis that they've done, and I've gotten through part of it. The white paper was a challenge, so I got through that, and now I'm looking at the other things they have out there. So I'll show you the links in a minute. Go out, please, and read through them and find out.
Is that the same white paper that you sign up for on their website?
That's the one, and then they've got other ones besides that.
That's not a white
Dallas
paper.
is a very deep
That's not a white paper.
technologist, so.
When I can understand it completely every word. White paper means shit I can't understand.
Is that the acid test, Paul?
Yes.
We're looking
So-
for a great paper.
Wait, I have a question with the drive testing. Is there any way we can participate somehow in that, like doing project with that?
That's what I'm going to propose here at the end, that we put together ideas, teams, and ask for development kits and to be part of that testing.
You know, if they might be interested in letting one of the vehicles, let's say that does the drive test, be a SIGINT van?
The SIG, yeah.
Signals Intelligence van.
Oh, yeah,
I mean,
okay.
it'll tell, it'll allow it to measure, but it'll also then put some clarity around what's actually happening.
I would love to propose it to them, and that's why I'm hoping that you guys can help today with ideas like this. Because if we can go back to
Gives you a
them.
real-time baseline to explain what's really taking place.
Where's that van coming from?
Oh, there's one here.
Is there?
If he tells you, he has to kill you.
Oh,
I don't need to know.
He doesn't have to kill you, but he has to maim you.
Oh, a whole new level.
There's commercial signal intelligence
Yeah.
vans too.
Sure,
Okay.
of course, right.
Yeah, so we have an opportunity here in the near future to be able to do these kinds of things. So I need your help, and let's put our heads together and see what we can do. Because we're getting a building block that nobody else in the United States except Phoenix, and maybe a couple other cities shortly thereafter, will have in this space at an economical rate to do things that the cellular guys can only do with very expensive equipment. They can't work on a battery for 10 years, and the Wi-Fi guys can't do it unless they connect and cobble together networks that could be very hard and difficult to manage and expensive. So we have an opportunity to build something that nobody else can do and make a name for ourselves in the world. So they have 35 plus private networks built out since 2007, showing real world, handling real world situations and whatnot. They've sold some of those to a company called Trillion, who has applications and an application stack that is suited for many of these private networks. So they're going to take over, the Trillion's going to take over these private networks and pay Ingenu. So Ingenu has some cash flow that they can help build out the network. So on November 10th, then Ingenu announced that they're going to build out 30 cities in the United States. Now, what I missed was here, John Horn. So John Horn is the catalyst that is changing things for Ingenu. They've been in the backwater since 2008. They've got some good customers and whatnot, 35 systems around the world. And so they've got perfected or a very improved capability. John Horn started 13 years ago at T-Mobile. He built up their M2M business at T-Mobile. They went about 4 years ago to Rayco Wireless. He built those guys up. They're machine-to-machine focused company as well. He built them up, and they were bought out earlier, the middle of last year, by Core, K-O-R-E. John cashed out then from Rayco Wireless, and he went to Ingenu, or OwnRamp at the time, and to the board of directors, and he said, guys, I've watched your technology. I appreciate what you guys are doing. You guys are not taking full advantage of what the potential is for your approach and your technology. If you will hire me, I will take you to the next level. They jumped up and said, you hired almost on the spot, and they said, what do you want to do? He said, let's change the name, and let's commit to putting that network in 30 U.S. cities. And then my 5-year plan is to build out the rest of the world and the rest of the United States as well. Well, what happened, I'm not quite there yet. So they're going to put 30 cities in. Dallas and Phoenix will be the first to be installed. And then they'll have that. So I talked about the coverage. So it'll go McKinney, Frisco, just south of Denton, west of Fort Worth to the edge of Weatherford, Waxahachie, and Mesquite. So and when they turn it on, they'll have 17 base sites, access points to start with to cover that area. And we'll be able to know then exactly what's going on, how well it works.
Ed, do you know what their pricing structure is going to look like?
No, that's what I'm trying to get right now. So I've been looking at the technology and reading through all the paperwork and whatnot. I'm trying to get the pricing for that and what we can do for.
All right, I get the pricing.
Yeah. So we'll get to that. So
I know
when
John.
we.
I think it's going to be similar to what others.
Yeah, it's probably going to be $1. It's going to be $1 device a year or something like that. I call them.
Yeah, there is one qualification. I'll talk about that more in a moment. Is the micro node radio module, and Roman may be able to talk more about that. But it's not cheap because they're doing a lot of processing to optimize the signal, and you can't do that with a real cheap.
Yeah, their average base station is about $150,000. So they're spending.
So are they rolling this out basically on their own business plan, or are they entertaining franchised, let's say?
I'll adjust that more. They're doing it in U.S. on their own dime, but elsewhere. Let me get to that. So when they do the U.S., they'll cover 100 million people by the end of this year. 100 million people in the United States by the end of this year. However, well, okay, so here, I had to do a screen capture, so sorry about that, it's very light. On the left-hand side, it's Dallas and Phoenix, and then shortly thereafter, during that time, is Riverside, San Diego, and Miami, Florida, Q1 into Q1. Q2 is going to be Houston, Austin, San Antonio, College Station. That's part of the well-aware private network that they're converting to be a public network, so they didn't sell all the networks to Trillium. They're converting some, and the well-aware network covers the Eagle, Ford, Shell oil fields, which start north of Laredo, south of San Antonio, over to north of Houston, and then they will turn up all these cities that are associated.
So I talked to Matt Harrison, who's CEO of WellAware, and he claimed, and I just wondered if you could corroborate this, or if this could live in the universe. He claimed that WellAware was, and this was about 3 months ago, the WellAware constituted 85% of on-ramp now Ingenu deployments.
Don't know about that point because
They
don't talk about.
I've done it WellAware. You know, I'm their story. I'm their poster child. I've done all over the world. I just wanted to.
Don't know about that part.
Anything.
All I've seen is that there's 35 plus networks that they've got installed, and they're converting the WellAwares, and they're going to cover all of South Texas there immediately, and then Dallas, Fort Worth, and then they'll expand.
I can see where all those statements are true. So kind of like converting oil field equipment monitoring stuff to make broader network coverage. It's kind of what it sounds like. We'll see the network here in Dallas here shortly, and we'll see how well it works for our applications. And that's what I want is us to look at what applications we as a community can put on their network and see the feasibility and the economic viability of those approaches.
So Ed, does Ingenu see Dallas and Phoenix as a test for themselves, like the first urban deployment of this technology? Or do they feel like that this is a done deal and they're just rolling it out?
They say they feel like it's a done deal. When I talked to the CTO, he had no qualms, and he believes that that the coverage in the cities will be more than adequate. It will be very efficient. So we'll see. It's all marketing. It's all fluff right now until we have some real world experience with it ourselves. And that's what I'm looking forward to is doing that sort of thing. So anyway, there's a lot of
What's the device
systems.
capacity per base station? Because that's a pretty fundamental constraint.
So there's
for
different
all of
ways to measure that. So if you look at the number of devices that can be connected, it theoretically could be several 100,000. But what you need to look at is what they call application throughput. They talk about that all of the, more than that, it's about how much data can be passed through an access point. And they're talking about 19,000 bits per second through each access point. So that's a significant amount of data per second that's able to pass through each one of these access points. And I'll show you in a moment why why tight transmit power control is so important in the need for more capacity. So anyway, there's going to be a lot of cities rolled out, first quarter, second quarter, third quarter, fourth quarter. So, and then go into them. So this is what the radio module looks like. They call it the micro node radio module. A lot of processing power on there to make sure that it's looking at the receive signal from the access point. It does analysis and says, what are the channel conditions? What are the interference conditions? What do I need? What spreading factors and protocol do I need to send back so I can send it at the highest rate and have the least amount of time that my transmitter is on to save my battery. So that's why it's got so much processing power. And then it sends that message back, immediately goes back to sleep. So that's why they can get there a long
More
time. with the
processing
battery.
means more battery.
But only for a few moments.
Okay.
I mean, they've optimized it. If you're using a lot of processing power, yes, but they're only using it for a second, for a few microseconds.
So basically, they send a burst to wake it up,
Yeah.
and then at that point, then the processing kicks in, and then when the transmission is done, they send a signal to shut it down.
But that's where we're getting
So-
a bit suspicious, because that's what Qualcomm's known for in LTE. They do
Right.
exactly the same philosophy, and it all comes down to a real simple constraint. What's the power consumption?
That's right.
Is we're building embedded devices around batteries that last a year, and we do energy harvesting. We're not interested in something that's just
For a cell phone that you charge every
top-down
day.
cell option, because we might as well just use a cellular one, because the price point's cheaper. And I'm really concerned about what us having to pay for their business model. $150,000 base station is
It's outrageous.
compared to
And I don't know, that's peak talking, so, we'll have to wait and see.
Same
Pete's
cost
right.
for Sigfox too, by the way.
It's an $8,000 base station is about LTE these days, and LoRa's in the $200 to
Right.
$2,000.
You're paying for the deployment of the business model, right?
Yeah.
Yeah, I mean, that's really what you're paying for. I mean, obviously, we all know, intellectually, what the cost of manufacturing the base station would be.
It's not 150,000.
Now,
Yeah.
and this is a public network, so that cost is not going to be on us as individuals.
Right, and,
It will
the
be
tower
in
access,
the
there's-
subscription
there's-
plans when you apply to it. So
Yeah,
they need to put in a
this
system that is economically feasible to support the customers they're going to have.
Private networking options, because no corporate's
That's
going
right.
to spend 150
Nobody
grand.
will do
So
that.
then the ecosystem shrinks and the business model starts to become a little backwater.
Well,
So right now, my focus is on the public network, and LoRa is going to be great for the private networks, it looks
Right.
like. So there may be these niches that are going to become visible
Right.
rather soon.
And Nick,
And anyway,
that's
that's
right ahead, right? They're dissuading, private network deployments, right, in that scenario now.
But you're talking about pricing for something they're not ready
They're
to
not able
deliver.
to.
Right,
When
exactly.
When an organization is pricing something they
And
can't
the other
deliver
thing
until
about
it's
that,
done.
right, so if you talk to somebody, if you talk to them or you talk to Sigfox, right, they have a rack rate in the base station. If you go into them and say, hey, I have 10,000 sensors that I'm gonna deliver to you on the network, magically that price is probably, I'm real sure, based on my conversations with them, that the price is gonna be manipulated.
And we don't know cost of goods, which is really the argument we're
Yeah.
having here.
Yeah, the thing that we're.
But we can pretty well assume what the bomb is, right?
Yeah.
So,
And what the good thing is that we all understand Moore's law. So technology every 2 years is going to double. So we're going to see the price come down, the power go up, whatever. So this is the initial stage. If it gets installed and proved out for certain applications, then it will begin that cost reduction curve and the power improvement curve over time.
So speaking of applications, what's it really, really good at? If we were to say this is the sweet spot for engineering, where does it sit?
So smart cities is one of the things that we really love to focus on, being able to control all the lights, the traffic, the water, the waste management, all the different city activities. Anything where you've got devices that you're trying to keep up with, it's too expensive right now to do with cellular. and the N-Wave and Sigfox guys don't provide enough throughput to do. So there's a spot in the middle here. So, and rely on the batteries, because they're saying their batteries will last 10 to 15 years as well.
Okay, so I'm talking to Wellware, who claims to be the number one customer, and say, hey, Matt, could you live with everything's got to go on my 32-byte packet? Everything. Your temperature, your pressure, your readings, your machine status, so on. He said, piece of tech.
Well, your security
He doesn't need
high bandwidth.
He doesn't need high bandwidth. He's just gathering some kind of treat like a lot of IoT apps. Very
Which is
small,
interesting.
little
I'm curious
snippets.
why this thing has so much bandwidth, because the two applications they're in doesn't need it.
Yeah, I see this.
Utility monitoring and oil and gas. I
The
mean,
more bandwidth, though, the less time the device is on here. So
well, that's what I'm wondering. If that's really the objective, is just to stay on the air as little as possible to have more nodes per base station.
Okay, so the thing about 900 megahertz A68 frequencies, they're not available everywhere in the world. A lot of places, they're not available. 433 is, or 315. So the 800, 900 megahertz, it's not necessary. The radios that you build for that will not necessarily be able to work elsewhere. 2.4 works everywhere. Different constraints depending on what the regulation environments are. Here in the United States, we can do 36 dB power, which equates to 4 watts of power, effective radiated power out of the antenna. And you can do sectorization and do 44 dB, which increases even more if you sectorize the signal. Europe may restrict it a lot more. So there's differences, but still the frequencies are available around the world.
And I have a question.
Yeah, exactly. One global radio, just depending on what the power is.
South America is not available. 3.4.
Is that what it said? No, 2.4 is.
Yeah, it's got it.
It's only the moon that's not really covered.
That you know.
If you get a strong enough antenna, I bet you can get it, right?
Oh, they just left it off. But the
Oh, they
2.4
left it
indicates
off.
it's the
Okay,
world.
because I-
They're just pointing out where 900, 433.
Okay.
I have to raise one objection, you've cut half of it zero.
I'm sorry. Yeah, hey, I noticed that. Yeah. So.
One northern extreme, not right.
So, I'm sorry you can't see this, again, a screen capture, but the top line represents the 3 key frequency bands that Wi-Fi users use, 1, 6, and 11. The second line here shows, I'm going blank. So, RPMA divides up the 80 megahertz worth of spectrum here into 1 megahertz channels. They have 1 megahertz guard bands. So when you overlay the Wi-Fi frequencies, you have a 1 megahertz band that you can use at the far left end, and this is what San Diego Gas and Electric uses. They cover their 4,100 square miles with this 1 megahertz band for all of their coverage area. Here between 1 and 6, you have 3 1 megahertz channels that you can use. And then above 6, between 6 and 11, another 3, and above 11 is another 3. And then you get into Global Star. And this is interesting here. The possibility is Global Star has satellite frequencies. It's called Channel 14. And they petitioned the FCC 4 or 5 years ago, and they are about to get a word back whether they can do it or not, to change this into terrestrial low power service, TLPS. If they do, they could take a technology like Ingenu and apply it here in this frequency. It's a dedicated managed system by Global Star. So stay tuned. That'd be interesting to see if that works out. If this technology does become adopted and useful for a lot of applications, Global Star may get into that business as well, using some technology like that or Ingenu's technology. So when you start looking at all the details and whatnot, I'm not going to bore you with this, but they're adding up all the dBs, the gains and the losses that are in the system, and then they come up and they figure out the coverage based on the real world and as well as the theoretical here. So whatever. There's a lot of detail in the material that's available out there. Now this is where I want to talk a minute about the tight power control that they apply to their access points and to their remote devices. So when you put a base station in and you do not have the ability to change its power and the power of the devices, then you're stuck. It's always going to transmit that power out to this defined area that access point covers. As you start reaching the limit of the capacity of that access point, if you put another access point in, you're adding to the interference and the problems with communication from the other devices. So now your system actually goes down in its ability to transmit pass information through it. By having tight transmit power control, both for the base station and the remote devices, as an access point starts reaching its application throughput limits, then you can lower the power of not only this access point, but the remote site. Or you can do it dynamically. You just put in a new access point. Immediately, the remote devices around that access point say, look, I see another access point that's a better signal for me, closer to me. I'm going to reduce my power just enough. That's the processing. That's the reason they got processors in both the systems that do so much calculation. They're able to lower the power so it's just enough to get to that one close access point. So now you can start putting in many more access points. Every time you put an access point, you raise your capacity by 19,000 bits per second application throughput. So it's a very powerful way, a very effective way of increasing the capacity of your system dynamically. You don't have to do anything, just pick the access point in out there.
You think SIGFOX can work?
No, they transmit at worst case, and they transmit at a signal they know that they can get through with the system. So if you want,
that's actually not correct. They both are dynamic, and for the most part, you don't care about the downlink because in your sensor networks, you're worried about the device.
Yeah.
The question I've got is a little different. Anyone heard of McKinney?
yeah,
We did all this years ago.
Oh, yeah.
Commercially entirely unsuccessful because it's not the simplest way to solve the problem. And certainly with Laura, the simplest way they solve it is they don't care. Every base station is literally a dumb protocol converter. You just throw another one in and fix the high frequency. It comes down to the clients interfering with each other, not the base station. That's what happens to the cellular network, which is dominated by down very sophisticated base stations to manage your spectrum with very, very little output. The MTM or the IoT position is completely the opposite. It always comes down to what you can do with your client. And you've got a choice of spending more power and compute, which they've done, or making the system simpler and more cost effective. And I guess the market will figure out what applications are going to work.
Well,
So
look where this came from. It came from Qualcomm.
That makes me instantly suspicious of power consumption.
So this slide is talking about all the different spreading factors that they use, different ways of managing and adapting their protocol, the signal that goes out over the radio.
But a spreading factor is a power control.
No, it's not power control, but it's just, this is an example of all the calculations they do to get the signal through. So, and the same thing here, they can actually have remote devices, 1,200 of them transmit at the same time, and they're offsetting by random chirps within a time frame that the base station is expecting from those devices. So that's another way they increase their capacity and reduce the amount of collisions that take place. So it's just a lot of sophistication they added into the processing of the signals that's coming in. It's just
Any information on interference with Wi-Fi or Bluetooth?
well, because right now they are choosing to use the frequencies outside of the
They're
Wi-Fi.
between the Wi-Fi.
Right,
They're in
and
the
those
Wi-Fi
predominant channels, everybody uses 1.6.11. So they're choosing to be outside of that, and then they've got channel 14 that becomes possible. If they need to, they can coexist with Wi-Fi, but that's how, I didn't explore that. So, but that's 40 channels that they have available. 80 channels total, 1 megahertz guard band.
Well, I'm not sure there is such a thing as if they need to coexist with Wi-Fi. It's not a valid question.
And that's just my statement. I have not seen any reports or literature of how well they coexist with Wi-Fi.
Because in a
They
residential
have to go
environment,
into
you've
the
got
Wi-Fi, because Wi-Fi is dominant.
there's gaps in a residential environment, but in a corporate environment, every frequency is built on every floor.
Right.
Not those guards.
Well, let's say,
Yeah.
but they're in the guard band, if I understand.
Yeah. If you're using 1.6.11, which 90% or 99% of the people use, then you've got the guard bands available to you. If you're going offsets, then yes, those renegades, those people that are doing that are into the guard bands here. So yeah, but most people choose between the three.
One of the things I found in China is that they use the world's worst RF components in their residential APs of all buildings. Those guard bands.
There's no guard band.
Exactly, it's all over the place.
And I think that's
So anyway-
a problem for Bluetooth Low Energy as well.
Right, exactly.
So it will actually interfere with Bluetooth Low Energy.
Yeah, because they're using a sub-part of the Wi-Fi things, yeah. I didn't look at that part. So we have a lot of things to learn. So I need your help, just keep on top of this and see what we figure out. If you go through the literature and their documents and whatnot, then you find out, they talk about the different capabilities. Their design is going to create a low-cost network in their opinion. So we'll have to wait and see if that truly works out to be that. Their capacity, they can go to high capacity and scale very well and very quickly. They're using the low cost or free spectrum of Wi-Fi. And they focused on long battery life. They got a lot of things that they're trying to do. Now they talk about the problems with 2G, the cellular network sunsetting, and that Ingenu will sign contracts to have their network available for 20 years. So for what it's worth, they believe that they're going to be around for a long time. If you commit to putting your equipment, your devices on their network, they're not going to sunset it. It's going to be available to you for a long, long time.
So what's their business model in terms of geographic coverage and moving out of countries or?
I'm getting to that. Just a minute. Hang on. All right. So, and of course, all the processing capabilities and everything they decide in, they get uplink, throughput, high throughput. They get acknowledged delivery, two-way communications. They can download. They have flexible packet sizes, and then they can download information, updates to the devices if they need to on an as-needed basis. Because their system is dedicated to machines, machines are the priority. In a cellular network, even 3GPP, the NB IoT standard, allows voice and data communication for smartphones and whatnot to have priority if necessary. So your low power WAN or your machine-to-machine IoT communications will have lower priority over these other communications that the cellular networks support.
But that's because of latency tolerance restrictions.
Yeah.
Voice is latency tolerant.
Yeah. So there's some things here that very different between machine communications and voice and data communications for smartphones and whatnot. So also the other thing that's interesting about Ingenu is that they are very good at handling congestion management. So if you have an emergency happen in an area, they're able to prioritize the information that comes in and be able to manage a sudden influx of devices reporting at the same time. So they built that into the...
Like what happens in a house.
Yeah, or a tornado comes through the area, and you get all these alarms going off if you're monitoring the houses, the different components that are in your city out there. So they thought about that, and they put it into their plans and their protocol. And of course, security is very, very big to me. So I'll make this, anybody that wants this PowerPoint presentation, I can send it to you. I'll put it on my, put it in the Dropbox.
Put it in the Dropbox.
It'll also, this whole presentation, I'm recording it, hopefully it'll be available after this weekend. And it'll be on my LinkedIn profile. So, but you can go to these sites. I'm going to give you several different sites you can go to and get the white paper and get the other analysis work that they've done and do your own understanding. The Vice President of Business Development is Derek. He's making himself available. Nice guy and very, very capable. So he'd be glad to talk and work with us. And what I'd like to do is create some thought leader. Our heads together, see if we can come up with ways that we can engage these guys to do drive testing and create solutions that we can put on their network and try out and display to the world what we're capable of doing if we have a connectivity piece that is useful and a worldwide standard. So here's the announcement. So Pete stole my thunder a while ago. So 2 days ago in Barcelona, John Horn makes the announcement that he's been approached by so many partners now that want to, much like Sigfox, put in networks in their countries. So now 25 countries around the world on 6 continents are going to put in a Ingenu RPMA network. And so here soon, half the world will be covered by their network, half the world's population. So John Horn said that his 5-year plan just now got squished to 5 months So that's an exaggeration. It'll probably take him several years to be able to build out these networks completely. But the point is, he has now been validated in the, at least in the investment market, by people that are entrepreneurs and willing to put their money into this to put up networks. So that's a very strong vote of confidence for him. So not only is Ingenu putting in their network in the United States, 30 cities here, but they're going to have 25 countries around the world that this network is going to be put in. So if it's not a good technology, there's going to be a lot of people lose a lot of money. And I don't think that's going to happen.
So how are they funding this? Because 17 base stations in Dallas alone, even if it's at your own cost, it's still a relatively expensive investment.
Yeah, well, they've had $118 million since 2011, several rounds. They sold some of their business to Trillium, so they have a cash flow there. Don't know the arrangements. And John Horn, when he came over, said he was going to bring some money with him. So he has a great reputation in the marketplace, having been at T-Mobile, Rayco, and took Rayco up to be bought out by Core. So he has a following, and they made this commitment. I don't know where they're getting the money from.
They're also working with multinational corporations on a country-by-country basis. Okay, so they're working on a partnership basis.
But 30 cities in the U.S., if you're having to put, 17 base stations is a
So
lot.
they're funding that themselves. The international, they're working with international partners. They're talking to, they're right now, I mean, I have direct knowledge of this, right? So they're directly talking to companies about international partnerships. Okay, like maybe, in Asia, they're looking at Japan, they're looking at Korea, they're looking at China, and they're talking to international partners about how do they go to market. So, and what they do is, none of this is solidified, but they're looking for it to say, it's a rev share, you invest, you work with the carrier relations, you get the tower access, you drive it in. We'll provide the technology, we'll do a rev share.
So I talked to their vice president and director last week, and when I realized, actually I started off talking to Michael, how's it make this?
Sirzinski?
Yeah.
Michael S. Yes.
Michael S. Okay, Michael. Sharp guy, serial entrepreneur, came out of Denver, came to Dallas, and is helping to build the tech community here as well. He's based in Cedars, just south of downtown.
Yeah,
south of downtown.
in Flower Mound.
So he works with Jackson and his group and Keith Alp a lot,
Yeah.
and with the startup community here. So he's responsible for Startup Week Dallas, which will take place April 12th through the 16th, and he's working with Dill on the DFW Hackathon that weekend, right?
Right.
So two different organizations, but you're collaborating?
Yeah, so we're basically promoting each other, and we're kind of end of their week, they end and we start up, so we're doing the weekend right after.
So the startup week is going to have 6,000
What
partners.
about a bake-off at Hack BMW? Get all the different
Right.
competing techs together. Like if Fox
So does anybody here know anything about Hack DFW?
We do.
Take it. Yeah.
Go ahead.
So Hack DFW, so it's just a weekend, we're bringing in 2,000 developers, engineers, designers to a weekend of building. So how it works is technologies from all these different companies come in, so Microsoft, Ingenu, whatever sponsor company comes in, they bring in their technologies, they provide a challenge, and up to, like it says up there, 20 to 25 teams usually pick up those challenges, build for that challenge, and make products for the weekend. So that engineers bringing in they're bringing an AP, installing it right in the middle of the event, and letting users use it to build for their particular challenge.
So it'll give Startup Week and Hack DFW some publicity and recognition, and it will give. But what I'm excited about is if we do a bake-off or if we just do the hackathon, what we have here is an opportunity. And this is where I want you guys to help me think about this and how can we move forward with this. No matter what the technology is, whether it's InWave or LoRa or 3GPP eventually, if they ever figure out what the standard's going to look like. What do they call that? A camel built by a committee? A horse built by a committee?
Built by committee.
Yeah. So whatever. What we have here is the opportunity to show what North Dallas, what North Texas can do in the world of IoT, with development, with products, with systems that we can create with whatever connectivity that we use and have available to us, and demonstrate to the world. We have the resources, the talent, and the ideas, the entrepreneurial spirit here to create those solutions. And we have we have a head start on anybody else that's coming out. Because there's not going to be another, other than cellular, which is a whole different animal, there's not a low power wide area public network yet. And there will be the end of March here in Dallas. Let's take advantage of it and see what we can do with it. It may not be the best technology after all. It may wind up having a lot of warts, and it may have to be changed, or we have to go to something else. But no matter what product we build, what solutions we have on the back end, we just need to find a connectivity that solves that problem so that we can connect all these instruments, objects, and devices that are in the world that we're trying to finally manage, monitor, and analyze for the future going forward. So that's my presentation. I hope that you guys got something out of it. I really enjoyed. I met Nick the other night, and I found out that he was a LoRa enthusiast and knowledgeable person. So come and heckle me. He's done a good job. and I appreciate Paul being here and being polite and nice to me. He can beat me. He is so good. He's always so good about bringing up good points. And Pete Denegi, thank you. We have some incredible talent and thought leaders and capability in this room here. So let's take advantage of it. Let's build our future here together, somehow working together. At some point we'll be competitors, I'm sure, in some ways. But right now, we have a chance to take advantage of our momentum. And we have tools that we can build on.
One more question.